Hi everyone, this is Mohit. Welcome back to my YouTube channel. This is the 7th day in our 60 days video series on statistics for data science, guys. So far, we have set up the foundation of statistics in our first 3 videos, and after that, we have started our first type of statistical analysis, that is descriptive statistical analysis. Now, in descriptive statistical analysis, we have covered two different type of measures: central tendency measures and measure of spread. Now, we have to plan out for the third type of statistical analysis, that is shape measures, guys. Right. Now, to understand the shape measures, we need to first understand the concept of density plot, which I am going to cover in this particular video, guys. Before starting, one request: if you are new to this channel, please subscribe the channel, guys, and hit the icon button so that you do not miss out any of the video. If you are liking the content, please like the video, guys, and let's get started. In order to understand the concept of density plot, guys, first we need to understand what is a histogram and how do we create them. Right? I'm pretty sure all of you know about histogram. That was very basic in our early classes, guys. We have learned about histogram and how do we create them. I'll just quickly revise that using a simple example, and then we will move forward towards the density plot. Right? So histogram, it is a graph, guys, which display the frequency of data lying in equal intervals or bits. Right? It consists of a series of bars. Right? So that bar will have represent the range of values on the x-axis, and on the y-axis we will have the number of data points or the frequency that fall within that particular interval. Right? So now let's understand these 2 points using a simple example. Let's say we have a company X and they have sold 32 items. Now here we are having the price of individual item which is being sold. So we have 32 numbers in our data. In real world, guys, we will have lot more numbers or lot more bigger size of data. But here, just to illustrate the histogram and the creation part, so that's why I have kept the limited numbers, 32 here. Right? So we have these numbers which are varying from $1 to $35. Right? Now, first of all, whenever you want to create histogram, we actually has to decide what should be the interval. Right? What should be the size of the bin. Now, there are two ways to actually find it out. So either you can decide the number of intervals or the bins, or you can decide the size of individual bin. Now, what I am talking about is, let's say if we are keeping the size of the bin as 5 or the interval size as 5, now this is how our frequency table will look like. Right? So now first bin or interval we have from $1 to $5. Now, how many numbers are there from our data? We have total 8 numbers, right? Which belong to this particular interval, right? Similarly, from $6 to $10, we have 6 numbers. You can check that out. Similarly, for the next interval, $11 to $15, we have 4 numbers, right? And then we'll keep on calculating the frequency or the numbers which are lying inside these intervals, right? So now once you have created this interval and the frequency table, now it's pretty simple, guys. You have to just create a histogram. You have to just visualize them. Now in the visualization, what we do, we have these kind of bars, right? On the x-axis of this, we will have the interval. Like in this particular case, we have intervals from 0 to 5, right? So this is 0, then this is 5, this is 10, 15, 20, then we have 25, 30, and 35, right? So these are our bins. So because we have decided over here, the size of our interval will be 5, right? Now the y-axis or the height of these bar represent how many numbers or how many data which are lying in these intervals, right? So between 0 to 5, there are 8 numbers. So that is why we have the height of the bar as 8. Now between 5 to 10, or we can say 6 to 10, how many values are there? 6 values are there. So that is why we have the height of bar as 6. Similarly, for other bars, we will have this, right? So that's how we create the histogram. Now, what it tells you, it actually dictates how the values are distributed in your data, right? So here we have the maximum values. So we can say most of the data points are lying around between 0 to 5, right? And then it is decreasing, the values are decreasing, then they are increasing, and like that, right? So now basically histogram tells you the distribution of your data in your data set, right? I hope this is clear, and this is very basic. I'm pretty sure everybody knows about it. Now, the second or better way, let's say in this particular case, we have only 32 numbers, guys, right? Let's say we have thousands or lakhs of numbers. In that particular case, if we are saying that between 0 to 5, there are 2 lakh values. Now, that number does not make any sense, right? So generally, when you have larger data set, then we move to the second type of histogram. We call it as relative frequency histogram. A lot of people know about histogram, but they are not aware about this term, relative frequency histogram. Now, how do we create? It's pretty straightforward, guys. From the histogram itself, we create relative frequency histogram, right? So earlier we had the absolute values or the number of values lying between these intervals. Now we talk about the proportions, proportion of values lying in those intervals, right? So as we know, there are total 32 numbers. Out of them, 8 are lying between $1 to $5. So in our first interval, in that case, how many proportion of values are lying in that? So it's 8 by 32, that will be 0.24, right? So 8 by 32, it's basically 1 by 4, that is 1/4, that is 0.25. Similarly, you will calculate for others. So 6 by 32, similarly 4 by 32, and then you have 32 by 32, then we have 32, this is also 32 and 32. These are the numbers we are having corresponding to the frequency, right? So these are nothing but relative frequency, you can say, or you can say proportions. Now, rather than using the frequency in your plot, guys, you use relative frequency, right? So earlier we had the height as the frequency. Here in relative frequency histogram, guys, we have the height as the relative frequency. Now you can see that. So this is 0, 5, 10, and like that. So in our first interval between 0 to 5, we have 25%. You can say 25% of the observations are lying between 0 to 5, right? So that is why the height of this bar is 0.25. Similarly, for the second bar, where the values are lying between 5 to 10, or actually 6 to 10, now how many of them are? 0.919, right? That is 19% of the observations are lying between 5 to 10. So that the height of this is 0.19, right? So similarly for other bars, we are creating them. So this is our relative frequency histogram. I hope this is clear. If you have any question or doubt, guys, you can write it in the comment section. I'll be happy to answer your question. Okay, so histogram is clear, and then relative frequency histogram, guys. Now we can move to the density plot. Now the very important point related to the histogram, guys, is that as you move here, the interval size was 5. Now in histogram, you can have any number for this, right? You can have the interval size of 5, 1, 2, 3, any number, whichever suits to your visualization, right? Or second way, you can say that the number of bars you are creating, because number of bars you are creating, in this case, there are 7 bars we have created. Now that depends on the size you will choose. As the interval size changes, the number of bars you will have, that will also change, right? That's pretty simple, right? Now, the interesting thing about histogram, guys, as you move or decrease the size of your bar, or your interval, actually, as you decrease the size of your interval, you will have more and more bars in your chart. Let's say I just have taken a hypothetical example where we have bin width is equal to 50, which is nothing but interval size 50. Like in this case, we had 5. Here in this particular example, we have 50. Now, if I reduce this, the number of bars will keep on increasing, right? So with bin width 5, we have more number of bars. And let's say if you reduce it to minimal values of 0.1, 0.001, or 0.0001, this particular graph will become more and more smooth, right? So like in this particular case, histogram with bin width is equal to 1, you have more smooth curve or the shape of your histogram, right? So that's the classic example, guys. When you reduce the bin width of your histogram or the interval size of your histogram, your histogram will look more smoother, right? Now, this is nothing but when you actually join the center point of all these histograms, guys, that curve, we call it as the density plot. Okay, so here, in which case I am talking about relative proportion. Okay, so I am talking about the relative frequency histogram. In that case, if we reduce the bin width very small, like 0.1, 0.00, depending on your data, when you have thousands of bars in your histogram, that will get converted into density plot, guys. And you can see from this. Suppose this is relative frequency histogram, then this curve we will call it as density plot. Okay, sometimes we call it as kernel density plot as well. We will talk about this density plot again when we will be talking about statistical inference, guys. There we will go in detail. This actually curve, there is a formula behind it, and we call it as probability density function. So this statistical concept we will talk about later. For the current, just to understand this density plot, we need to understand this histogram, guys. Okay, so right now we are just learning about the density plot. What is it? We'll not go into detail of it. Later stage, we will talk about that as well. Now, so density plot, guys, it's a representation of the distribution of a numeric variable, right? Histogram also we were using to understand the distribution of the variable. Similarly, density plot is also very popular in statistics, guys, to actually understand the distribution of different variables we have in our data set, right? And remember, this is valid only for numerical variable. Sometimes we also says that it's a smoothened version of the histogram, right? So again, used for the distribution of numeric variable, and we smooth out the histogram like I explained in the last slide, right? So now this was our histogram, and the green one represents the histogram, guys, and then when we join the center point of these, that will create the density plot, guys. I hope this concept is clear to you. There are few important points you need to remember related to this density plot. Here I am explaining because we are going to use it for the shape measures. In the next video, I'll be talking about the shape measures. There I'll be using the density plot, right? So that is the reason why I'm explaining density plot right now, guys. Now there are few points, remember them. So this chart is a variation of histogram, absolutely. And which type of histogram? Relative frequency histogram, guys. Relative frequency histogram that uses kernel smoothing. So this is the technique we use to smoothen out our histogram. I randomly said that we will join the center point of these bars, but that's not the way to do it. There is a kernel density estimation process we use to actually find out this curve, right? So we'll talk about that later in our upcoming videos, guys, on statistical inference. Okay, so basically ultimately we are smoothing it out. Now the peaks of the density plot, wherever it lies, that will display where the values are concentrated. Now this is similar, same interpretation we have from histogram as well. Wherever we have the peak in our histogram, it means most of the values are lying over there, right? Or the values are concentrated over there. Similarly, wherever you will find the peak, like in this particular case, this is the peak. So the majority of the values, or you can say the values are concentrated around this 120 value in our data set, right? Now, the third point, an advantage density plots have over histograms is that they are better at determining the distribution shape. That's why we are learning it, right? So in histogram, you keep on increasing this, like the number of bins, you will keep on having better and better shape of your data or the distribution, and that's where your density plot comes, right? So that's why we use density plot to understand the distribution of the data. Now, this is the most important point, guys, which we will be talking in detail in probability distributions, which we will start in our statistical inference. That the area under this curve, right? So area under this curve, we actually have that value as 1. Okay, so we use this density plot to say that what is the proportion of values which are lying between, let's say, two numbers, between 140 to 160. For that, we can calculate this area, and to calculate this area, we use integration, guys. So here we use integration from from mathematics to calculate this. So integration application also we can see in density plot, guys. We'll talk about that later. But one point, remember that area under this density plot V is actually 1. Okay, area under the curve is equal to 1. And it represents the proportion of values lying between two values, right? So if somebody asks what is the proportion or the proportion of values lying between 80 to 100, for that you need to calculate this area between 80 to 100. That number will be the proportion of the data that is lying between 80 to 100. I hope the density plot is clear, guys. As I said, we will discuss about it density plot in detail in the later stage as well. When we will start with our statistical inference, there we will talk about the continuous probability distributions, and then this point will come again, right? But here, to understand the shape measures, we need to understand what is density plot. It's basically how your values are distributed in your data. That's what it represents, right? Thanks for watching till the end. I hope you understood the concept of density plot, guys. This density plot we are going to use in our next video to understand different shape measures we have in descriptive statistics. So one request, if you are new to this channel, please subscribe the channel and hit the icon button so that you do not miss out any of the video. If you are liking the content, please like this video and my earlier videos in the same series. If you have any question or doubt, write it in the comment section and I'll be very happy to actually answer those questions. Please share this video with your friend to reach more friends so that it can be helpful for others. Thanks again. See you tomorrow, guys. By that time, take care and keep learning.